Hello, I'm Daniel Russo. I'm working on homework number 1, problem number 3 for EL6303. This one has been giving me some trouble, so I've decided to try to work through it a little bit on camera, and maybe I can come up with a solution by the end of it, but I think we'll have a couple of options to go by, and hopefully we'll see what the outcome is. Now, the question is to prove or disprove if probability of A given B plus probability of A not given B not equals 1. Then A, B are independent. So we kind of have to prove independence. And to prove that independence, we need to get this statement in the form of the probability of A, B equals the probability of A times the probability of B. So that is what we need to prove independence. And we can't really use it. Now, a couple of things I've written down that are just general theorems that we may be able to use to help prove things are the probability of A plus B is equal to the probability of A plus the probability of B plus minus the probability of AB, which may or may not become useful. Another one we have is probability of A is equal to 1 minus the probability of A minus A naught. Probability of B is equal to 1 minus the probability of B naught. And those are move around, communicative in a way. Same goes for probability of A naught equaling 1 minus the probability of A. Some other ones I've written down are the probability of A is equal to the probability of AB plus the probability of AB naught. Similarly, probability of B is equal to the probability of AB plus the probability of A not B. Now, I see the conditional probability, so my first idea is to attack that. So the probability of AB over the probability of B plus the probability of A naught, B naught over the probability of B naught is equal to 1. So still trying to get to here and trying to figure out what theorem could help me. Now, I don't see any knots there, so I think the idea would be to try to remove them somehow. Now, the probability of AB over the probability of B is already in a format that we'd like. So if I change this possibly to something more acceptable, that would be best. Now, my options for A naught, B naught are somewhat limited, but I believe a derivative of this would be B naught is equal to the probability of A B naught plus the probability of A naught B naught. So as we can see, we have this here. We can shove that into this equation space, and we can also use probability of B naught is equal to 1 minus probability of B. We can put that in the lower slot and see if that helps. Now, we have the probability of B naught minus the probability of A B naught over the probability of 1 minus the probability of B. So quite an expression growing now. Still have B naughts, and but we're hopefully we can see what we can do about changing that. Now we could work to maybe distribute out some of the B naughts, and maybe that would, or maybe, you know, try to get rid of the denominator and see what we can do there. So we multiply both sides. By 1 over B naught, 1 minus probability of B. Sorry. Probability of B, 1 minus probability of B. Same here, probability of B, 1 minus the probability of B. Probability of B, 1 minus the probability of B. You can see that. I'll try to make sure it's visible. But multiplying both sides by that, crossing out some things here. So on this one expression, we have the probability of AB multiplied by the B. The PB cancels there, so that's just 1 times the P. So probability of 1 up there, and because that cancels there, the probability of B is multiplied by the probability of B naught minus the probability of A B naught wow. The last piece here will be probability of B multiplied by 1 minus the probability of B. So let's see what we can do if we distribute that all out. Probability of A minus the probability of AB. That's probability of AB minus the probability of AB times the probability of B plus the probability of B multiplied by the probability of B naught minus the probability of B multiplied by the probability of A B naught, which is equal to the probability of B minus the probability of B times probability B, or probability of B squared. So we got a lot of things going on now. Now, how this exactly will shake out is where I'm not exactly sure, because I might make some mistakes here. I believe that the probability of B times the probability of B naught will lead to the null set. So I believe that is correct, dealing with that. So that disappears for us, thankfully. Try to get rid of those B naughts still. Now, we have a probability of AB, which we'd like to keep around, eventually leading to an AB. We don't have any probabilities of A unless the commutative property works here to make this a simpler expression. So probability of AB could be subtracted to the probability of A times the probability of B squared, which would then lead this to 1, I believe. So now we have the probability of A, and then minus the probability of B, again multiplied by the probability of A, B naught. So this would possibly change to the probability of A multiplied by the probability of B multiplied by the probability of B naught, and this will lead to the null set, thus removing that piece of the expression actually. Which leaves us with the probability of AB, and with the probability of A equaling the probability of B. Oh, forgot to see the probability. I would say this. I believe this becomes 1. And this 1. Now it's possible some of those simplifications were not correct, and possibly maybe a substitution might have been a mistake somewhere. Possibly this can't be done unless we know it's mutually exclusive or independent, for instance, but we're trying to prove its independence, so it's hard to do there, but let's see here. Now we want to get probability of A and B. Maybe we can probability of AB is equal to probability of B minus the probability of A, well, plus the probability of A minus 1 is now close, but no cigar, as they say, as the old saying goes. Might be out of luck with this attempt again, but there may have been a mistake I could trace back later. Of course, maybe this is 0, but for now I'm going to have to leave it where it is, and hopefully maybe submit a follow-up video when I figure it out, and have been, reviewed with maybe others. But for now, close-ish. But I think I need to focus more on some of these other simpler probability function, how they work when handling the math situations. But for now, that's the end of problem number 3. Thanks for watching.